Hello, hello, hello. Welcome to the first lesson of 5.2 right angle trigonometry. That's right. New poster. School Rumble. Great comic. It's a comedy. I recommend it. 5.2. We're going to start off with some review of some stuff which is really year 7 that you will need. That you will need to do bearings. So we're going to go jump straight into bearings. 5.2 trig, it's mostly the same as 5.1, but bearings is new. So I thought I'd start off with that. And then we'll be doing more of the same stuff later on. But hey, this page is what I want to look at here. So this is a bit of theory of corresponding, alternate, and co-interior angles. So I put little notes in the text here telling you what to write down, because otherwise I'll forget to. But for now, nothing to write. Just watch until I say so, because I'll be moving quickly. Corresponding angles. F shape. So the F shape here in red is showing you that these two angles are equal. So corresponding angles are equal, and they, in this case, they're both equal to 130 along that line there. And there's an upside down F over there. That's still an F. In this case, they're both 70. Equal. So that angle equal to that angle equal to angle. Now we have this only occurs if you've got parallel lines. If you have lines which aren't parallel, so if I draw lines over here that aren't parallel, you can't say that this and this are equal, even though it's an F shape. No. Or for example, these two, because the lines aren't parallel, not going to work. So you need parallel lines, and the transversal is the line that cuts them. Moving on, just going to keep moving. So examples here. Corresponding angles. In blue here, those are equal. Green there, those are equal. Orange are equal. Gray, those are equal. And then over here, we have things which aren't corresponding angles. These ones we'll learn about later. But none of these. That's... Oh, I like that one's obviously not. That one's obviously not. This one, you think, oh, there's parallel lines. Those should be equal. No, because we needed the horizontal lines to be parallel. We needed that one and that one to be parallel, but we didn't get it. So no, it's a really good example, that third one. Keep on moving. So let's work out some angles here. If that's 120, then T is 120. Now, vertically opposite angles. Those are vertically opposite angles. That's another bit of geometry. Vertically opposite angles. That's like where you have the cross. That's equal to that, and that's equal to that. And then S is also 120. You could do that by vertically opposite angles or by using corresponding angles. Done. Parallel lines. This one just threw that in. They did hard stuff like this. They say, well, 4x is got to be equal to 48 because those angles are equal, so x is equal to 12. We won't be meaning that in this topic, those types of questions. But all we need to be able to say is that those two angles are equal. Keep moving. Going to go a bit quicker than on my previous videos. Alternate angles. Now, these are the Z-shaped ones. So here they've got green. The Z going across. And I'm going over the top of it here. That's our Z. These are alternate angles because they're on alternate sides of the line. They're on opposite sides of the line. One's on the left, one's on the right. But they're not adjacent. They're not adjacent would be 50 on that one I just drew, but no. So opposite and attached to different parallel lines. They're equal as well. Very important. Equal. So corresponding equal. Alternate equal. Just to show you, it's not just the ones on the inside. It's not just the 60 and the 60 that are equal. No. The 120s, the other side, they're equal too. So you can have Zs. I know you don't think of it as a Z. Oh, went back up. But this is fine too. Ugly Z, but still a Z. Parallel, transversal, 120, 120. Keep moving. So that's equal to that. That's alternate angles, even if they're a bit ugly. That is alternate. Okay. And then some examples here. Yellow is equal to yellow, blue is equal to blue, red is equal to red, green is equal to green, etc., etc. And these ones, not alternate. Same again. That one's obviously not. That one's obviously not. And this one, we needed those two lines parallel but we didn't get it. So no. Okay, gonna keep moving. So super hard, oh my God question. If that's 62, what's that one equal to? Yes, 62. Last one. This is the one which people forget because these ones, they add up to 180. Not equal. So you look here on the left, the 130 and the 50. Co-interior angles, the C shape, they are equal. They add up to 180. 130 plus 50 is 180. And on the right, 110 plus 70 is equal to 180. That's what we're going to use to find missing angles here. And the word is supplementary. Supplementary, meaning adding to 180. So examples, if that's 59, what's y? Well, you go 180, take away 59. Calculator can do that. Take away 60 and plus 1. So 121. Well, 59 plus what gives you 180. So here we go. That's how we do it. I don't like that subtraction method where you cross out that and make it a 10, and that's a 7. 10 take away 1. So, yeah, no, that's slow. One more. So you could do this whole thing without co-interior, but we are going to use co-interior. 180, 58 plus what gives you 180? 122. And then these now are just adjacent. You could say, 122 plus 58 and 58 plus 122. So that's how we do. Okay. So that was quick fly through of the 3 types of angles. I had a picture there, but it's gone, so I'm going to pause. Alrighty. So here's a quick summary. Corresponding angles of parallel lines are equal in green. Alternate angles of parallel lines are equal in blue, others on opposite sides of the transversal. And the last one there, co-interior angles of parallel lines are supplementary. That's in capitals there, supplementary. I will write the word transversal there just in case you don't know it, the thing that cuts the parallel lines, and add to 180. So I'm going to pause here, give you a chance to write that down. Pause, 3, 2, 1. Alrighty, on to 5.2. So we go over here and the exercises, we got 2 lessons here. Well, 1.5, doing an exam. The aim is to complete 1 to 15. So everything but the final question. That's an extension question. So that's what the aim is, questions to complete. I won't provide an advanced set of questions for this one because we just need to practice that. Everyone just needs to practice, get used to all these things. So let's get some examples of bearings. This is all about bearings. We're going to go with the very first one. If they give you just an arrow there, that arrow means north. And if you have something which is going directly north, a straight line, the path that they are on, the bearing they're on, the angle they're on is 0, 0, 0. That's it. So I want you to copy all of these down. There's a bunch of them, but just first one, 0, 0, 0. Next one, if that's north, and we're going never, and south, obviously, east on the west. If you're going directly east, you're going to write that as 090, because from north, you are going 90 degrees this way in a clockwise direction. So this is 90 degrees clockwise, gives you that. Next, north, south, east, west. South is 180 degrees from north, so it's 180. You don't need to put a 0 in front of that. You do not need to put a 0 on that. So that's our bearing there. If you're here and you're going this way, it is 180 degrees. That's your bearing. Last one, going to be of the 4 cardinal points of the compass. If you're going directly west, it's not 90, it's the long way around. It's 270. So 270. That's the way we do it. So then, I'm just going to throw some at you. If we say down here, what is directly southeast. Directly southeast, well, that's 90 plus another 45. So southeast is 135. What about northwest? So you could do it the long way around. It's 90 plus 90 plus 90 plus another 45. 270 plus 45 will give you 315. Easy way to do it is 360 take away 45. But that's it. I'm going to scroll down. So the top three will disappear, but the bottom three will still be here. We're going to keep moving. And then hard ones here where, well, it's not pretty anymore. Like this one. So they give you that. So it's 20 degrees south from west, 20 degrees off the west. And then we go, well, what you could do is that's 20. Well, that's 70. And then it's coming around 180 on top of that. So it's 180 plus the 70, 250. And the only tricky ones where they, let me pause, think of some hard ones for you. So I thought of one. So what we need to remember is that there's not just north, northeast, etc., etc. There's also in between these ones. So there's north, northeast. And over here, east, northeast. East, southeast. South, southeast. So all of these as well. South, southwest. West, southwest. West, northwest. So I know that's a lot to draw, but I think a lot of people forget this. Hey, myself included. So if you can see the top two, you start with the north. The bottom two start with the south. The left, ones on the left start with the west. The ones on the right start with the east. So it's you starting from north, south, east, west. And then how far off do you go? Well, what's half of 45? It's 22.5. So this is 022.5. But do we do decimals for bearings? I'm going to look that up. Google that. And the answer was not clear. So some people would say 022.5 is okay, but others would say, no, it has to be 023. So you have to round it. So I'm just going to leave that there. All the questions I've seen in a book, they're always to the nearest whole. So like the easiest ones, they give you more like this. This is all they give you. They say that's 60. And you say, well, what's the bearing? And you just have to write 060. That's all you got to do. Just remember to put the O in front of it if it's under 100. That one there was a tough one in the middle. So I'm going to scroll down in 3, 2, 1. So the next thing, this is there. A lot of people make mistakes because if you have to read it very carefully. So this top one, bearing of B from A. So this is A, and this is B. And if you drew a line joining them, a line, it would be great if that line actually goes to them. What is the bearing of B from A? So from A, it's that angle, 045. If we have another example here, we'll put A here, and we'll put B down here. And we'll say, this time we'll call it 45 that way. What's the bearing of B from A? Well, what we need is this angle from the north down to B. 135 is our answer there. We'll do one more over here. If we have B, we got A, and this is our angle of 20. What is the bearing of B from A? You have to go from the north, and you have to go all the way around there. So it would be 270, but 20 short. So it's 250. It's not the full 3/4. Now we can use the exact same setup here. I'll leave them on the screen. You'll be able to see them just is, if we have the same setup, what is now the bearing of A from B? It's a totally different question for each of these ones. It's going to give you an answer which isn't simple. You're going to have to use a lot of co-interior angles, alternate angles, corresponding, whatever works to help you get it out. So this is geometry. So we said that's 45. I'm going to do, and that's 45, and that's 20. So now we got to go in red. We have to do some work. First things first, you have to draw north. That's not red. That's red. First thing, draw north. Like whenever you're doing this, the very first thing is I do draw north. Why did I do 45 down there? It's clearly not 45. It's clearly 20. Glad I caught that. Silly mistake. So the first one, 45. Well, one way to do it, I could do this. And by alternate angles, that's 45. Those are alternate angles because the norths are parallel to each other. So the bearing of B from A is the 180 plus the 45, 225. That's your answer for that one. For the next one, we got 45 there. So that's 45 there. Again, alternate angles. So what we could do is 360. It's going round that way. It's almost a full revolution, but not the final 45. So 315. This one here, that's our north. It's 20, oh, that one. Ooh, well, that 20 degrees, I have to make it clear. Make it even clearer. Where is that 20? That 20 degrees is actually just in the corner. And I've drawn it. I have to draw it right in there. That's our 20. So how could we proceed from here? You could think of this as a right angled triangle. And that's a right angled triangle there. And it's 180. So just if you want to cross here, then there. So that's 180 minus 90 minus the 20 will give us that angle there, NBA. That was a fluke. I have just fluked the NBA. And then, yes, I like basketball, so I'm happy with that. So that angle there in the corner is 70 degrees, and therefore that's our bearing, because that's perfect. That's our north angle going down. That's where it gets tricky. So I used alternate angles, angle sum of a triangle. You could have used other ones. I'm going to pause here, give you a chance to copy that. Pause in 3, 2, 1. Okie dokie. I'm scrolling down, and you'll see a little note here. You can now do questions 1, 2, 3. You now know enough from the book to do questions 1, 2, and 3. If you want, you can stop the video here and just do that. But I'm going to keep going. So I've got examples from the textbook, which I start off just with bearings, but then I'm going to move on to trigonometry. So the bearing, nice and simple here. A from O, that's 120, done. O from A, that's that angle all the way around there. Ooh, how am I going to do this one? 120. I think I'm going to use alternate angles. That's 120 there, plus the 180. 120, 180 plus that 120 is 300. So alternate angles. That one and the 120 are alternate. They're on opposite sides of the line. That's it. Scrolling down here. 3, 2, 1. Next one. Oh, scroll down. Well, I could bring the question up. I gave myself lots of room for no reason. A bushwalker walks 3 kilometers on a bearing of 060 from point A to point B. Find how far east point B is from point A. So from point A east, They only care about how far east they went. So that distance there, which I've drawn on the bottom, that's all they care about. Call that x. If that's 60, no, it's very small there, but therefore this one is 30. That's so tiny. I'm going to draw that bigger so you can actually see it. Why 30? 90, take away 60. Oh, there's arrows everywhere. So at this point, I'd redraw it. The diagram gets a bit messy. Redraw. That's our x, that's our 30, and 3 kilometers. So the geometry part is over. Now it's just trigonometry. We just got to find x and then adjacent over the hypotenuse. Yeah, I'm speeding up now. I'm not doing as much working out. 3 cos 30. Calculator finally getting some action. It's been waiting on the sidelines for all this time. 2 to 1 decimal place. I will do the 2.598 ... and then round it. I've gotten used to that. So I can always make sure I've done it. So it was geometry to start, working out all the angles, and then trigonometry. So this is geometry and trigonometry combined. Scrolling in 3, 2, 1. Oh, I gave myself room here. Last one. Example 20. Fishing boat starts from O. Bearing of 160 to point B. How far east of its starting point? Another east question. So I'm just going to extend that line, the south, and it wants east again. So that's our x we're trying to find. Only caring about that. And if that's 160, that angle there is 20. And then redraw. This is all I care about. Right angle at the bottom. X here, 20 in there, 75 there, 75 kilometers there. So this is part A. Sine 20 equals x on 75. 75 sine 20 equal to x. Calculator. .651. We want how far east to the nearest kilometer? 25.6. 26 kilometers. Nearest kilometer. But B, this is where it can get a bit tricky. What is the bearing of O from B? Oh, no. Not. I was thinking of a different type of question. So I'm just going to go to green here. Again, first thing first, draw north. So we're from B. So the angle we want is from north, going around in a clockwise direction. It's almost 360, so it's a little bit off. What I can do, if that's 160, then in there is 20 by co-interior angles. So co-interior angles are supplementary. Just a reminder. Whoa, you can't even see that, can you? No, you can't see that. I caught it. I'm going to pause. Glad I caught that. It's good I got 2 monitors so I can see on the other monitor what you see. So that's it. So 20 is in there. And so therefore the bearing, it's 360. Take away the 20. So B, 360. Take away that. That's not a 6. I'm pretty sure that's a 2. 360, take away 20. It's 340 is our bearing. That's of O from B. So you notice it's just too small. So I'm just going to zoom in here. So I'll zoom in 3, 2, 1. Zoom. Small diagrams are no good. We need big, huge diagrams. 160 there to there, 20 in there. And then the bearing is from north going all the way around to there. So it's 360, take off that 20 is our bearing. That's why it's 340. All right, going to finish up by going back to the start. Oh, I'll pause there. So, last little thing, what you need to be able to do. You need to be able to identify bearings on a diagram, e.g. 060 degrees, 359 degrees, anything in between. Find angles on a diagram. This is corresponding angles, alternate angles, co-interior angles, vertically opposite angles, all that year 7 geometry, adjacent angles, all that stuff. Angles adding to 90, complementary angles, angles adding to 180. That's all important now. We need that. Find missing sides and angles using trigonometry. It's all the stuff from 5.1. Last one's tough. When no diagram is provided, draw one. So you've got to read questions carefully. So that's it. I'll scroll up to the top, but it was just questions 1 to 15. Scrolling up. 1 to 15. Lots of time. Take your time. Practice, 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 practice. Good luck.